Hi guys, Miss Zimmer here with volume part 2, hopefully my last YouTube video this school year. So let's get started. Now, although it's volume 2, there is surface area and volume. Tonight I remembered to bring my surface area and volume formula sheet. This formula sheet is posted in the materials section. So if you haven't printed it out or at least taken the picture and put it on your desktop so that you can access it easily, do that. Now, first question. I'm just going to roll through the 9 questions from this, and you're like, 9 questions, it's going to be short. Some will be short, some will be a little bit longer. So, all right, it says a triangular prism has base edges of 6, 7, and 9 centimeters long. So it's a triangular prism, so I drew 2 triangles, connected them with rectangular sides to make it a prism. And let's just make this, 6, 7, and 9, like this side from here to here is 9. So 6, 7, and 9 are our side lengths. That doesn't look like a 7. Okay. And it says its lateral area, is equal to 352 centimeters squared. So that means that if these are the bases here and here, the lateral is what's going around the figure, because lateral are the sides of the figure, and this one's laying down. So all the sides are going to be the rectangles going around this way. So that's its lateral surface area. Now, it says, what is the height of the prism? So we're looking for h. We're not looking for the height of the triangle. We're looking for the height of the prism, which is the distance between those 2 triangles or those 2 bases. Because if it's a triangular prism, then the triangle must be the base. Now, the formula for surface area, T or SA, you can see it both ways. T or surface area, total surface area or surface area, is perimeter times height plus 2 bases. Now, they're telling us the lateral perimeter times height right here is already 352. 352 is equal to perimeter times height because this is the lateral surface area and these are the bases. We don't really need the bases, so they're gone. So the lateral surface area equals perimeter times height. Well, we know the perimeter. 6, 7, and 9 added together is 22. So all we have to do in that one is 352 divided by 22, and our height comes up to 16. And good warming up, quick problem to remind you of lateral surface area, because we're going to be needing a lot of laterals and not as many bases today. Now, the second problem. If you're looking at my picture and going, I have no idea what that picture is, well, it was supposed to look like this one right here. And if you're still not sure what this is, and I'll start with the base, is there's a half of a circle here and a half of a circle here. Okay. Now those continue downward. So if I took the middle section out, which is just a box, and I took those 2 half circles and I put them together, I'd actually get a full circle or a full cylinder. And the middle is just a rectangular box. So the question is, find the surface area. So we need the surface area, or total surface area of the prism or the rectangular prism in the middle, that's the box, plus the cylinder. But the problem is we don't need all of this rectangular prism. So let's see what we do need. Let's talk about those 2 formulas. If we just put those 2 formulas together, we would have a problem. I'll show you why in just a second. Perimeter times height plus 2 bases. That's the formula for a rectangular prism. This is supposed to say RECT for rectangular. Sorry, it doesn't really look like it. And then for our cylinder, we have 2 pi r times the height plus 2 pi r for the bases. Well, okay, the cylinder, we actually have the whole cylinder. We have the bases, and we have the curved sides over here and here. We have the curved faces. So we're going to need the lateral, the curved part, and we're going to need the bases. Even though the bases are split, we need both bases. But let's look at the middle. We need the lateral, the distance going around, but the cylinder, the way the cylinder caps the ends, we're not actually going to need the ends of these. We're only going to need the 4 rectangles going this way. So let's think about that. Let's call these the bases and just make it standing up, you know, with the bases kind of like that rectangle, the bases facing us like this, and we can just eliminate those. So if that is the case, if that's the base, then we need the perimeter going around this direction. Now the numbers that they have the numbers going across here is 8. So that means our diameter is 8, or our side length of our rectangle is 8, and 4. Looks kind of like a square on my drawing, but that's the best I could do. It's not to scale. Now, based on that, the perimeter, we're going around the rectangle. So we have 2 times 4 plus 2 times 8. Typical rectangle, 2 times the length plus 2 times the width. Now, the height is the distance between the bases, and we're just talking about the rectangular prism, and that is given as 11. Sorry, I didn't add that in earlier, 11 meters. So now we don't want the 4 by 8 bases, so we skip the bases because they're inside the figure, they're not on the surface. And then we want 2 times pi times the radius. Our radius, since our diameter is 8, our radius is 4, times our height. Now, the height here, they're talking about the height of the cylinder. The cylinder goes this direction, up and down. So its height is 4. So this height is the height of the prism. We had our prism laying down, so we want the height going this way, but that height is going up and down for the cylinder. Plus 2 times pi, again 4 squared, for the height of our radius, our radius squared. So I've got over here, just to kind of simplify this, I have 24 for the perimeter times 11. That comes out to 264. And then I ended up with 4 times 4 is 16 times 2 is 32 pi here. And I ended up with 4 squared, 16 times 2. I ended up with another 32 pi. It says type an exact answer in terms of pi. One of the tricky things in this homework is that you have to follow what kind of answer they want. In this one, it's in terms of pi. So I can't get rid of the pi's, but I can add them together. And now my answer is 264 plus 64 pi square meters, or meters squared. And this is the answer. Since they want it in terms of pi, and we can't add those without changing it to a decimal, like 3.1415, then we're done. Okay. Now, another option, instead of doing the rectangular prism here, you could do each of the 4 rectangles going around and add them all up, like each rectangle separately. So you'd have 4 different rectangles, and then you'd have the cylinder. So that's another option for that lateral surface area, and then the cylinder, and then together. All right, number 3. Now, with number 3, you kind of see I've got a sort of a diamond shape, roughly, and this is a pyramid at the top and a pyramid at the bottom. So that I don't have to exercise any poor drawing skills here, I can probably do it if I work at it, but I think you want this video to be as short as possible. So let's go ahead and do this. Let's do one of these pyramids, not two. All right. So here's one pyramid. You can imagine the other one at the bottom. In fact, I think my drawing skills are up to task today, or at least close. It was all right. So let's go ahead and just go with the top. We can double it in just a moment and worry about the bottom because it's saying they want the surface area. I don't know why I'm writing the whole word, essay. Now, if we have that pyramid at the bottom, the base is not actually on the outside, right? The base is inside the figure. So all we need is the surface area. Now, 1/2 PL plus a base. That's our formula for the surface area of a pyramid. But the base is actually, this base is inside the figure because there's that extra pyramid down here at the bottom. So that base is going away. And we don't just have one pyramid. We've got the one at the top, the one at the bottom, both surface areas. We've got two. Good news is that means that 2 times a half, the 2's cancel. All we have to do is multiply the perimeter of the base times the slant height. Now, this is where it gets a little tricky because the slant height's not given. So here is our height coming down the middle, 7. Our slant, as we learned yesterday, is on the side of the triangle, right angle here. That's our L. And then to connect those up is halfway across one of those squares because it's a square base. And that's a 7. And what they have on the sides is an 8 and like an 8 over here to let you know that that's a square base. So what does that mean for our triangle? Well, our triangle, this side here is half of 8, so it's 4. So our L value is 4 squared plus 7 squared equals L squared because L is our hypotenuse in this right triangle. Okay. If you have a missing height, you can use Pythagorean theorem. If you have a missing L value, the slant height, you can use the Pythagorean theorem. Or if you're missing like a side length, you can, and you have the height and the length, that L length. So continuing, now that I've got that, obviously this is 16 plus 49 equals L squared. Add those together, 50, 65. So our L value is the square root of 65. So I can just put square root of 65 right there. And our perimeter is the distance around our base, which is 4 times 8. And then multiply it all out, and we get to the nearest whole number. That's nice when it's rounded to the 10th. Sometimes it gets a little dicey. So this one is 258 meters squared. Okay. All right. On to the next one. I told you these were going to take a little bit more effort. Luckily, sometimes the volume ones are a bit shorter. We're not quite there yet. We've got another surface area, and then we'll switch over to some volume. Now, this one, I've kind of written all over it a little bit, but this one is a big tall prism with a pyramid on top. So here's our small prism. And one down here. And not long enough. Excuse me. 1, 2, 3. Okay, close enough. There's your there's the prism at the bottom, and then at the top we have a point up here at which we have our pyramid. This one's dashed a little bit. Okay, maybe if I move this over a tad, you can see it a little bit better. All right. Okay, so now we have our picture. Rectangular prism at the bottom, pyramid on top, and it's asking for surface area of that figure, and it wants it to the nearest whole number. Whole number is good because there's not going to be much rounding error when it's whole number. Now, the numbers that they have given us here are 8 and 8. So that means our base down here, our base here, and our base up here, square. Both are square. Now, this one's on the surface because it's sitting on that base. This one's inside the figure, so we really don't need that base at all. What we do need is, first, our prism formula, perimeter times height, plus 2 bases. That's our prism. Pyramid plus 1/2 PL plus a base. Well, we already said, hey, we only actually have one 8x8 base. We have this one. This one's on the inside. So we don't need the base of the pyramid. We don't need the base. We only need one base total. So what we'll do is we'll just get rid of these two, because there's only one base. That's it. We do need the perimeter times height, which is the lateral surface area here. We need the 1/2 PL, which is the lateral surface area here, and just that one base. So let's go ahead and slap on that 8x8 here, or 64 for our base. For our perimeter, it's the perimeter of the base, so 4 times 8, our 32 up there. Our height of the prism is given as 9. And then we just need 1/2 perimeter. Well, we already said the perimeter of the base again, where perimeter of the base down there is the same as perimeter of the base for the pyramid. That is also 4x8, or 32. Excuse me, 4x8. And now we just need our L value. What we are given up here, and I'm going to get rid of this scribbling for the base so that you can see it. What we're given is a height, a capital H height for that pyramid. There is no H value. We need the L value. The L value, probably the best place to put that, I'm going to move this out of the way. Let's go ahead and put that on this side. Our L value, just like in our last picture, is over here. Connected up, right triangle, right there. I can even get this a little bit out of the way. Put that in the back. So, what's half of our base? 4. Our height, 8. We need our L value. Looks familiar, just like the last one. So, for L value, 4 squared plus 8 squared equals our L value squared. And that comes up to, just cut into that chase for the L value, the square root of 80. And we'll plug that right on in there. All right, let me make sure I have all of our numbers. Yep, and yep. So once you put that all into the calculator, sometimes you might want to do that one piece at a time. One piece, but if you round anything, just be really careful. Keep it a couple places until you get to the very end, and you should have, in this case, 495 meters squared. Okay, I usually will change some of these to whole numbers first before I'm putting it into the calculator, just so that I have less steps. Okay, and you might want to put parentheses around some of this. Oh, this is supposed to be plus. Sorry, that's plus the base at the end. That would have been bad. So this, gotta drop that down. Okay, moving right along. Now they do this weird thing. They give you this really pretty pentagonal prism, but if you look really carefully, there's another pentagonal prism inside. So for example, if you had a box and the cardboard was really thick, you wouldn't measure the block box on the outside, you measure it on the inside for the volume. So in this case, obviously this box is a pentagon on the end, and there are these really slight lines on the inside. So we're totally going to ignore the stuff that it says on the outside, and we're only going to look at the stuff that it says on the inside. And we get to use our trig from area. Yay! Anybody who was skipping pentagons in the area lesson, I came back. Okay, so here is our pentagon. I'm going to kind of draw it a little bit sideways like they do. That just gives it perspective. I know it looks kind of weird, but doing the best that I can to get you a decent picture. All right, and then the same one kind of back here, about that length. Not too bad. Something like this. Not exactly, but I'm trying. Okay, I'll try a little bit harder. Okay. Let's get the space a little bit over here. I might give up in a second because I'm not doing a very good job drawing this one. Okay, and that's probably why they have the pentagon in the front, but they don't show the pentagon in the back because it's really difficult to kind of draw that thing in. Okay, so something like this, and that, and that, and the pentagon's kind of back there. Okay, so pentagon in the front, pentagon in the back. Here's this, sort of like that. Okay, I'm giving up. All right, so we have a pentagonal prism. What's really important is not the fact that I'm doing a terrible job drawing. The fact is that we need to use the measurements. Let's pretend like this is the inside of the box. This is 6 centimeters across, and this is 10 centimeters on the side. And we need to find the volume. Luckily, volume for the prism is area base times height. And you're like, oh, super simple, 2 numbers, I can just multiply 6 and 10. No, that's not what it means. B is the area of the base. So the area here is 1/2 AP or 1/2 ASN, remember that, times the height. Yes, the height is 10. Yes, the number of sides for pentagon is 5, because this is your pentagon. Okay, that's the height of the prism. Done. The side length is 6. Like we're rolling right along. And we have a 1/2, but we're missing the apothem. So remember, from the center of the pentagon, perpendicular to the side, that's the apothem. So how do we find the apothem? Trigonometry. We take our triangle, okay, and we say, okay, there are 5 triangles in a pentagon. 360 divided by 5 gives us 72 degrees. So this angle would be 72, but I'm only looking at that angle, half of that, which is 36. You're like, oh, that I remember 36 and I remember 22.5. 36 was for the pentagon, 22.5 was for the octagon. Now, we're looking for A. We don't need this triangle on this side. We're just looking at this one triangle. We know that half of this side length is 3. So now, right triangle trigonometry, this is our angle. This is the opposite side, the adjacent side. Tangent of 36 is equal to opposite over adjacent. So now we take our calculator, and as we do when the variable is at the bottom, okay, some more looking back, okay, we do 3 divided by tangent of 36. And 3 divided by tangent of 36 tells us that A is approximately 4.1291. You're like, why am I dragging this out? Well, it says we're going to round to the nearest tenth. When something is rounded to the nearest tenth, it gets tricky. You don't want to round before the end. In fact, it just says round to the nearest tenth as needed, but this is the only number that needs to be rounded. It's in my calculator, so I don't have to round it. I can just take this number, boom, and it's in my calculator times 0.5, the first number, times 6, times 5, times 10, and 619.4. Got it. And that is centimeters cubed. And we have now solved the volume problem, so we're cubing everything. Just imagine a tiny little cube. The last thing that I used was a die, and I didn't bring it back. but imagine if I was holding a little cube in my hand, a little bit about this high, this wide, this long. If I had to fill this up with that little cube and just fill it up with water, pour it in, fill it up with water, pour it in, fill it up with water, pour it in, I would have 619 of those little cubes and about 0.4 more. So I don't want to fill it up with a little cube, but that's what that means. You'd be filling it up with a little cube, a little bitty box cube, and pouring it in. Okay, so that's what they mean by cube, centimeters cubed. Number 6, we've got 6, 7, 8, 9. This one should go pretty quickly. And this one is easy to draw, so you don't have to be too patient for me. Okay, if you can see, we've got a cylinder with a hole in the middle. So cylinder, hole in the middle, and here's the bottom. Same hole in here that we can't see because it's at the bottom. All right, so don't even worry about what you see there. Usually the picture just shows you that cylinder with a hole. Sorry about that, cylinder with a hole. Our height, 5 centimeters. Our diameter all the way across from one side of the cylinder to the other, 6 centimeters. And our distance across the smaller circle, that's the diameter as well, is 4 centimeters. They say find the volume of this solid. So there are all sorts of like mechanical things that have holes in the middle. Any kind of screw or nut or anything that's got a hole. So it's clearly a good volume problem. What's the volume of the metal, or how much do they need? So we're going to start with just pretending like it's a cylinder, regular cylinder. Don't worry about the hole in the middle first. Pi r squared times its height. Now I use capital R because there are 2 cylinders here. There's the little one in the middle that we're going to take out, but we're focused on the big one right now. So pi, the radius is not 6, the radius is 3 squared, and our height is 5. Now we want to take out the other cylinder. So that other cylinder is pi little r squared times the height. They are the same height. That radius is 2. So they are practically identical, but one is a little bit smaller than the other. So here, one of the things that's important is to read. It says the volume of the solid round to 1 decimal place. So luckily it does not need to be in terms of pi, so we can solve it. I always like to put as little into my calculator as possible so that I don't have data entry error. So here I've got 9 times 5 or 45 pi. Here I've got 5 times 4, 20 pi. So all I really need to put in my calculator is 25 pi. And by the way, if they said to answer in terms of pi, it would be 25 pi centimeters cubed. So now let's just find out what that is. 25 pi is 78.5 centimeters cubed. So again, to fill this up, it would take 75 of those little cubes, 1 centimeter by 1 centimeter by 1 centimeter. All right, moving right on to number 7. Oh, super great. It's a pool. And when they say a pool, they want a rectangular prism. It says the approximate dimensions of a swimming pool are 158 feet by 82 feet by 6.4 feet. So a 6.4 foot deep pool that's 158 feet long and 62 feet wide. That's a pretty good sized pool. Really good sized pool. Like my backyard couldn't fit that. So let's just do a quick rectangle. I'm not even going to dash those sides. I think you can tell the box. Let's put 158 here. This is not to scale. Obviously 82 here, 6.4 here. Everything is in feet, as it would be talking about a pool. They're asking us, 1A, find the volume. Volume equals the area of the base times the height. Well, what is the base? It is 82 times 158. It is the area of that base. The height of the pool is 6.4 feet. So you're like, wow, there must be a catch. And by the way, if you're finding the area of a box, you can also use the shortcut formula, length times width times height. You can use that for a cube. You can use that for a rectangular prism. You cannot use that for a triangular prism. It won't work. If it's a triangle, if it's a pentagon, if it's an hexagon, it has to be a box, square or rectangular box. Now, multiplying that out, we will get 82,918 cubic feet. Now, that's good to know, because if you go to the pool store and they ask you how many, you're trying to buy chlorine or whatever you're going to put in your pool to keep it clean, they may ask you how many cubic feet your pool is. And if not, then they need to know the measurements, and then you try to figure it out. So it's always good to do that so that you're pouring the right amount of ingredients. Now, another thing, how many gallons of water? So you want to find out, how much water am I going to pay for to put in that pool, because it ain't free. So it says 1 cubic foot of water is about 7.48 gallons. So how do we find how many gallons? We multiply that by 7.48 gallons, and we'll answer our second question to the nearest integer, so the nearest whole number, and that will be 620,227 gallons of water. So when you get a water bill that is $500 or $600, you'll know, oh, that's the month that I filled the pool. Okay. So part A, the volume. Part B, how much water. Moving right along. Problem number 8, 2 more to go. So that was not too bad. I just like it because you might actually have a pool someday that you have to work on that with. But hopefully it's not quite that big. 620,000 plus gallons of water is a lot. Okay, next one. Here is a cone. Good old cone. Here is an X value, and our height going from the tip of the cone to the center is 6. And they don't say units, so let's just pick, let's just say U. Okay, and it says, find the value of the variable in the diagram. So they want us to find X. X is a radius, so they could have named it R, but they just chose to name it X. The volume for a cone, looking on your formula sheet, is 1/3 pi r squared times the height. So it's a circle, but 1/3 of it. Okay? All right. I'm sorry, it's a cylinder, 1/3 of a cylinder with the same base. They tell us the volume is given. As you can see, they give us our picture and they give us a volume over here. Our volume is 18 pi. So it's in terms of pi. The one thing we do know in the picture is our height is 6. Well, if you see pi on both sides, you can cancel it. 1/3 of 6 is 2. So on this side, we've got 1/3 times 6 is 2, r squared. This side, we only have 18 left. You can divide by 2. And r squared equals 9, so the radius is 3. It can't be -3, so it's got to be +3 units. I don't think they actually ask for units there. They just say, give me a number, and it would be 3. So another nice one. I threw in a working backwards problem instead of working forwards on this volume. Okay, the last one is a combination problem. They call it a composite, similar to the one we did earlier, very beginning, with a cylinder and a rectangular prism. This time we have a cylinder, and on the ends, it's a sphere. Yay. So Sort of like if you look at any like a caplet pill, that's what that would be. It's a caplet, right? All right, rounded ends. So the middle portion is our cylinder. Do our cylinder. Boom. And then we got our circle. All right, on the ends. Now, we have a radius given of the circular part, which is 10 centimeters, and we have the length here of 12.5. Some of you might think, oh, it's going to go from here to here, but it doesn't. It goes, when they say the side length, it only goes from the nearest point to point. It may not look very clear there. Okay, so watch out for that one, just in case you think it's going all the way across and you need to subtract anything from that. You don't have to. Okay, so we're going to find the surface area first and then the volume. So surface area, we need a cylinder and a sphere, but we don't need the ends of the cylinder. So the lateral surface, or the rounded part of the cylinder, is 2 pi r. That is the circumference of the cylinder, and then times the height. So that's our lateral. We could put 2 pi r for the two bases, but those bases are not being included because they're rounded ends. So instead of adding on the bases, we're going to add on the surface area for our sphere, which is 4 times pi r squared. So lateral for the cylinder, whole for the sphere, because if you take both of these spheres and collapse it, put them together, you get one sphere. All right, let's put in our numbers. 2 times pi. Radius is 10. It's hard to see whether that was a radius or diameter. It's a radius. Height is 12.5 centimeters. Don't need the centimeter in there for now. Plus 4 times pi times our radius again of 10 squared. Again, I'm going to solve everything that I possibly can before adding it together. This is 250 pi, and this is 400 pi. So I have 650 pi for the calculator. Love that pi key, makes it easy. 650 pi gives us 2042. 2042.0. Now it says round to the nearest tenths. If you do not include the 0.0, my math lab will mark it wrong. So include the tenths place, even if it's 0. Don't discriminate against 0. Okay, so that's our surface area. Now we need to figure out our volume. Luckily, volume, unlike surface area, we never have to take off part of the formula. We never have to worry about lateral versus bases. It's just fill it up. So this time, instead of surface area, we're going to use the same problem, but we're going to use volume. Volume of a cylinder is pi r squared times the height, and the surface area is volume of a sphere, 4/3 pi r cubed. All right, so now pi, radius of 10 squared, times the height, 12.5. Here, plus 4/3 pi r cubed, 10 cubed. Don't forget it's cubed now. It is not squared. Put that on the inside here. So I'm going to separate this again. I've got 12.5 times 100. Oh, obviously, times 100 is going to give you 1,250 pi here, plus 4,000 over 3 pi here. So I'm just going to put those together. 1250 plus 4,000 over 3, and then times pi. And I get 8,105.8. I think it's rounded to the tenths. It is. And that is centimeters cubed. Okay. If you want to try to put all of that into your calculator at once, good luck, but be careful because MyMathLab is not going to give you any partial credit. So it's worth doing a little bit of extra work, writing it down first and making sure that what goes into your calculator is correct. Okay? Because if you're doing it incorrectly multiple times, even though you're setting it up correctly, it can get really frustrating. So watch all of these. They're changing on you. Some of them are to the 10th place. Some of them are exact form. Some of them to the nearest integer, which means to the nearest whole unit. So make sure you read carefully because I don't want you to have to do the problems over and over again. All right. Good luck on your last 9 problems here. And then all you have to do is the practice test, put it all together.